Hello and welcome. In this video, we're going to talk about the very basic concept of standard deviations. When it is a good idea to use standard deviation and when it is not such a good idea to use standard deviations. So let's say we have two stocks, stock one and stock two, and we don't know much about these stocks' nature. We don't know much about their fundamentals and technicals. All we know is the price point. So stock one, you can see is priced relatively lower, starts with $8, here kind of closes with $6.2, kind of varies in a range. Stock two, on the other hand, is priced somewhat high, starts with $125, and let's say it's closing here at around $103. Like I said, we don't know much about the fundamentals of these stocks, and we don't know much about the technical analysis that we can perform here. All we know is the price point. Now, in such cases, with just this much information, how would you choose a stock? So let's calculate the average price for these stocks. Stock one is on an average price $6.76, and stock two is priced $116.60. Now, if I ask you to choose one of the two stocks, which one would you prefer with just this much information? A lot of people, in my experience, tend to go for stock one because they say this is priced low. This is a perception. They feel it's priced low, it's reasonably priced, and they feel the stock two is expensive. We actually can't say that unless we know a lot more about these stocks. Another reason behind this choice would be that if, let's say, I'm putting $500 in the market, then how many units of stock one would I get? I'll get 73, 74 units of stock one. And for the same $500, how many units of stock two would I get? I'll get just 4 units. So a lot of people feel getting more units of a stock is a good idea, but that actually is not the case, because what matters is how much money you're putting in the market and how the stock gives you the returns on that. A few people go a little ahead and they say that we would want to compute the standard deviation because that is the measure of volatility. So what they will do is they will calculate the standard deviations of these stocks. And for the stock one, this is 1.03, and we can just copy this formula for stock two. So now this is all the more confirmed that stock one is a better choice for some people because this has a lower standard deviation compared to stock two. In general, we are told that lower standard deviation is better. So if something varies less, it's more consistent, and who doesn't like consistency? But is this the right way to look at this data? So the formula for a standard deviation looks like this, where xi is every single value and mu is the mean. So we are taking the difference between every single value and the mean and squaring it and adding it up. And then finally, we are averaging it. So if it's a population, you will put n here for the number of observations. If it's a sample, you will do n minus 1. But numerator is more interesting for us today because with this approach, if we tend to compare stock one and stock two, you can imagine that stock two, being a stock on a higher magnitude, will mostly tend to show higher deviation too. For example, if I have values like 10 and 9, and if I take a difference between them and I square them, this would be 1. But if the same values were changed to 190, now I take the difference and square them, the difference would be 10 and the output will be 100. So this is 1 versus 100. Is this a fair comparison? When the variables in a data are on different magnitudes, is it fair to do these comparisons? The answer is no. Let me quickly bring back the standard deviation for this data here. So then what is the way out? How do we proceed with this? If I still want to do these comparisons and we clear that standard deviation might not be the right measure because it depends on the magnitude of the data. In the denominator here, you only have the counts, which will be one and the same for both these stocks in this case. So what is the way out? How do we solve this problem? There is an easy solution. That's known as the coefficient of variation. You divide the standard deviation by the mean and then do the comparison. This is a measure of relative variability. What did I do? I just divided the standard deviation by the mean. Now, surprisingly, if you see, which one varies more now? So what you're able to uncover is actually the stock one seems to be varying more, a lot more compared to stock two. But the standard deviation gave an exactly opposite picture. So what is the takeaway? The takeaway is that whenever we are doing comparisons between two variables and they are not on the same scale, Something is in units, something is in hundreds, something is in thousands. It's not a fair comparison when you compare them using standard deviation. Don't conclude that the standard deviation is more or less when the variables are on different scales. If the variables are on different scales, either you bring them to the same scale first and then do the standard deviation computations and do the comparisons, or you go with the right measure, which will be the coefficient of variation used when the variables are not on the same scale. If you would like to know more about such basic concepts related to the data, which could lead to very different conclusions in a detailed project, I'm providing a link in the description about the basic issues with the data. You'll get crystal clear understanding of what are the primary issues with the data. That's it for now. Thank you.